Okay, I think we're actually live. I will double check that to make sure it's currently recording. You don't want actually you can't even see the top of your head because of how I changed the camera. Y'all are less visible. Y'all are, what was that? Oh, fine. I want to look at that later, just not right now. I don't got time right now. Ember Learning Labs. Should just do it with the audio, that would be faster. Oh, freaking new phone. Ember Learning Labs.
Ember Learning Labs.
Thank you. Look, we are in fact live. Yeah, great, there we go. Okay, wonderful. That's working just fine. Like it. I do want to record local, though, because just in case.
Can they hear us?
Not well, just a little bit.
That was one of the things when I was watching the videos. I was like, I can't tell what question Alexa's asking, so I don't know.
Yeah,
what
I may set up a use the second mic at some point and let that be a pass around mic or whatever, in case whatever, depending. I generally don't do that because I don't want people to be like, oh my gosh, I don't want people to hear me. But you know, maybe we won't care.
Asking math questions.
Right, exactly. Okay, so number 10 is 0, 2 pi over 3, 4 pi over 3. 12 is pi over 4 and 5 pi over 4. 14 is pi. 16 is cosine of theta plus cosine theta, cosine 2 theta, all over 2. 18 is 8 over all of 3 plus 4 cosine 2 theta plus cosine 4 theta, sorry. Number 20 is cosine 2 theta. 22 is negative cosine 2 theta. See, we went through, that's it? Yes? Great. Okay, what questions on those? 12. Let's do it. I think speaking of audio, I was going to do this last time, my audio is way too hot. Lamo. Yeah. That's 2 theta minus the tangent of 2 theta, tangent squared theta, hello, equals 2. We're supposed to find all the solutions between 0 and 2 pi. So what should we do?
Do we turn everything into it? Because all of those have like an identity. So do we turn all of them into their identity?
That's gonna, you could like turn it like, you could, but that's gonna be a mess right now. I would wait to use like the double angle identity and or the Pythagorean identity, all that stuff. I would do something else first. What else could you do first instead? What do those terms have in common? Tangent 2 theta, right? So we could factor out a tangent 2 theta. Pretty sure we did one like this in class, but that's fine. What's left when I factor out a tangent 2 theta?
1 minus tangent squared theta.
Minus tangent squared theta equals 2. Oh, we can't do that. We can't do that yet. What's wrong with this? What's wrong with this picture?
Because the 2's on the wrong side?
Yeah, well, it's not because the 2 is on the wrong side, but because...
Tangent 2 theta doesn't work?
Well, it's because it's factored, and if it's all factored, it needs to be, to do something useful next, it needs to be equal to what?
0.
0,
Okay, so
right?
Factor it, move over the 2, and then we can
Yeah.
factor and do
And then hopefully do some different kind of factoring. Yes, 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 yes.
I need my secondary color.
So I'm going to subtract 2 from both sides. So I'm going to write it in descending order. So negative tangent squared, no, tangent 2 theta, tangent squared theta, plus tangent 2 theta minus 2 equals 0. Problematic, right?
Does it factor now? Like, would you parentheses factor?
It doesn't really. In order to factor it, we would want this one to be positive, right? So we could divide everything by -1, right? Get us closer to something useful, right? Turn this into the tangent of 2 theta times tangent squared theta minus tangent 2 theta minus 2 equals 0, right? So I can see that somebody is watching this stream. So if you're there, say hi.
The 2's going to be positive now.
Yes, it is. Thank you. The 2 is going to be positive now. Okay. Now what?
Can we factor something out now? Oh yeah, we can factor out the tangent 2.
We can't. Why not?
Oh, because the 2. Never mind.
Yeah, because it's not in all of them. We could factor it out of the first 2, but that's like only so useful because we'd still have to deal with the 2.
What is the 2 multiplied onto the tangent? Is that what? Like, how is
This
that
is plus.
It's like this. Tangent of 2 theta.
Oh, okay.
Yeah.
I thought you were asking me a different question. I was like,
I-
this is positive.
I kind of think we are going to need to use our double angle identities right now, unfortunately, right? Because what else are we going to do?
Nice. Okay,
Do
fine.
we also use the tangent?
I'd leave that for now.
Okay, okay. Well, if we go with what I did, if we go back to the
Okay.
top and we just factor out the tangent 2 theta, then we're left with 1 minus tangent squared theta, and then we turn the tangent 2 theta into its 2 tangent theta over 1 minus tangent squared theta, and then the 1 minus tangent squared theta is on the bottom and the top are going to cancel.
Okay.
So you're left with just 2 tangent theta.
Okay.
and 1 tangent.
So what you're suggesting is to start from here, factor out a tangent 2 theta. 1 minus tangent squared theta. And you're wanting to change this one or this one?
The one on the left. The tangent
Okay, so use the double angle identity now. Okay.
2 tangent theta over 1 minus tangent theta squared.
2
Squared theta
tangent theta
over 1 minus tangent squared theta.
over 1 minus tangent squared theta.
And then you're multiplying it by something that has that in the numerator, so it's going to cancel.
Theta equals 2. So it cancels.
So then you're just left with 2
2
tangent theta equals 2.
tangent theta equals 2.
Divide it all by 2, and then you're just left with tangent equals 1.
Tangent equals 1. And then we got to finish that out by doing the inverse tangent of 1, right? Of 1 equals theta. Okay. What's the inverse tangent of 1? Pi over 4.
And then if you do the quadrant 3, it's going to be pi over 4.
Pi over 4. And then tangent is also positive 1
Quadrant 3.
in quadrant 3. And so 5 pi over 4. So for clarity, just to be clear, again, we could have gotten there the other way we were headed. Probably would have ended up with this ultimately anyway, probably. going a longer way, but we would have gotten there eventually.
Did we change it to the inverse tangent?
Yeah, that's what I was asking.
When we're looking for the angle, that's what the inverse tangent means. That's what we're always doing. I just actually wrote it out this time. That's what we're always doing.
It's just been kind of an applied step.
Mhm.
All right. Okay, what were the answers to 10 again?
Answers to 10 again were 0, 2 pi over 3, and 4 pi over 3. If you missed some of them, you probably just canceled stuff too early, if I had to guess. What other questions do we have, kids?
18.
18 is secant to the 4th theta. We're supposed to write it without any powers in it. Okay, so what can we do?
So 1 over cosine to the 4th.
It is 1 over cosine to the 4th, that's true.
We can make it the 1 over cosine squared.
We can. 1 over the cosine squared. That's true. Now what can we do?
We can turn that into 2 over 1 plus cosine 2 theta squared.
That's
We're using, let me write out the identity. So we're using cosine squared theta equals what? Which one are you wanting to use?
1 plus cosine 2 theta over 2.
over the okay.
It's the power reduction, but it turns it into the, that same category of things, but
And
yes.
Since it's 1 over cosine, don't we just flip the fraction?
1 over, here in a second. So it's 1 over all of that squared, 1 plus cosine 2 theta over 2 squared. So before we do any flat fraction flipping shenanigans, what should we do there? Yeah, go ahead and do the squared, right? So in the numerator, we got a binomial squared, so we use the binomial squared theorem, or you can FOIL it out manually, either one, whatever floats your boat. All right, and turn that into 1 plus 2 times cosine 2 theta plus cosine squared 2 theta all over 4. And then you are right. So this 1 divided by that, this is just going to get flipped and multiplied times 1, right? We can deal with that. You follow? Your face looks confused.
So multiplying it times 1, is it going to be like 4 over 4? Or
So you're taking you're dividing by fractions, so you're flipping it and multiplying by the reciprocal, because that's how you divide fractions, right? And so it's going to be 4 times 1, and then this is like 1 over 1, right?
Okay, well then we have another square that we want to deal with.
That is true. So where we're at right now is 4 over 1 plus 2 cosine 2 theta plus cosine 2 theta. Yeah, I wrote that. Just uglified, but I wrote it.
you just said it weird.
Cosine squared 2 theta, yeah.
You said cosine 2 theta.
Oh, well, that makes sense. Okay, great.
Okay, well then we turn that into the thingamabob again.
We do turn it into the thingamabob again.
English at its finest.
At its finest. So 1 plus 2 cosine 2 theta plus 1 plus cosine 4 theta, right? Over 2.
What? Why is it 4?
Because theta is 2 theta. So 2 times 2 theta is 4 theta. Like the one we did in class the other day. Like putting it in here.
Okay.
Yeah. Yeah. Okay.
Just have the logic this steps.
The
Yep.
stuff in the parentheses is the cosine squared.
Yes, it is.
Okay.
Yeah.
Well,
These
then-
is these. So now what?
Well, that's over 2.
Yep.
We don't want.
True enough. Yeah, we just got to clean up at this point, right?
Yeah, we don't have more powers.
That's true. It's just ugly. So we got to like make it less ugly, and then we're done.
Okay. Well, if we flip that right fraction.
Can't yet, because it would have to all be on there.
I forget how these rules work.
Yeah. Because of order of operation. So if we,
We can just multiply both those bits by 2 over 2.
yeah, we can. So we get like terms here, right? So this turns into 2 over 2, and this turns into 4 that over 2. And then we can get everything with a common denominator, right? So we've got 4 over 2 plus 4 cosine 2 theta plus 1 cosine 4 theta all over 2. Now what? We've got this divided by this, so we flip this one and multiply. So the 2 would be multiplied times the 4, and the 1 times all this mess. So then the final answer, probably, is 8 over 2 plus 4 cosine 2 theta plus, oh wait, there should have been a plus right here, right? And 1 plus 2 is 3, right? That's plus cosine 4 theta.
Okay, then that's the final answer.
That's as simple as it gets. Well, it's not as simple as it gets. That's as simple as it gets, but that's what they're asking for.
I think we got
You can't square root both the things if there's not an equal sign.
Right. Yeah, you can't take square root of both sides unless it's equal to something. Or the 4th root or
That would be nice.
whatever else. Yeah, you can't just poof, seek it.
Okay, 20.
Sure. Times it. Yeah.
Yeah, I got a grand total of 1 correct.
Oh yeah, 20 is a good little problem.
Is it little?
Well, the answer is cosine 2 theta. So the answer is little. Ooh.
Number 20.
So whoever you are watching this stream, you should say hi.
Trying to pressure them.
Yeah, they need to be pressured, whoever they are. 20. I don't know. It could be Aiden, I guess. Cosine. And there was somebody in Algebra 2. They even said hi. Cosine 4 theta minus sine 4 theta. Yeah. And we're supposed to write it without any powers.
Do the cosine squared and sine squared. So then we can change it into their probably the same thing.
I wouldn't do that identity right now. In fact, I wouldn't use any identity first if it were me. There's definitely an easier way to start this problem. There's an algebra way to start this problem. No, it'd have to be an equals. It is the difference of squares. That's exactly right. So let's do that. So what would it factor into as its difference of two squares?
Cosine squared plus sine squared, and then cosine squared minus sine squared.
And cosine squared minus sine squared theta. Absolutely true. Something should be screaming at you right now. Pythagorean identity. One of these is going to disappear into something simpler.
We're going to have a minus and a plus sine squared theta.
Oh, I know, the one on the left, it's just one.
The one on the left is just one. That's true. That one turns into one.
How?
You tell me.
I do not know that.
Yes, you do. What identity did she say?
Pythagorean?
Yeah, what Pythagorean identity? There you go. See? I told you you did. Okay. So now we've got cosine squared theta minus sine squared theta.
Isn't that still difference of sines? I mean, difference of squares?
It is, if we want to go that route. Sure. You could. So you could turn this into cos. Ooh, what am I writing?
Do you not want to do 1 minus cosine squared with the angle? Because we just got 1.
Well, this side turns into 1. 1 times that is that.
Yeah.
Yeah.
Multiplication.
So yeah, you could turn into cosine theta plus sine theta times cosine theta minus sine theta. And you might be tempted to circle it and move on, but that's not really right. Because this is still the squaredy bits. Just unfoiled.
How do you know when to use the power reducing things and the Pythagorean? Because they both use squared. Does it?
Well, it depends on your goal. So like on these one, it's specifically asking on the power, so it's specifically asking to get rid of powers greater than 1. So that's going to probably be power reducing. But sometimes if you use Pythagorean to like poof stuff away, then you can, yeah. So the answer is whatever works at the time. Use whichever one does good. So
You change it into the power reducing things and then stuff cancels. Okay.
that's true. I feel like there's like 2 different ways. I want to try this a different way. But yeah, let's do the power reducing one. Sure. So what are we going to turn this one into?
One plus cosine 2 over 2.
1 plus cosine, what am I writing? 1 plus cosine 2 theta all over 2 minus, what do we turn this one into?
1 minus cosine 2 theta over 2.
Minus cosine 2 theta all over 2. We got like terms. We should distribute this negative to make sure we know what's happening. So it goes here and here, which is going to turn this into a plus. So plus a negative, right? That's going to make sure that's when we,
Then the 1 minus 1 gets rid of that.
right.
But then we have 2 cosine 2 theta over 2.
Sine 2 theta over 2 cosine 2 theta. Yes, that's true. Okay, so I'm curious about something real quick. What if we use a Pythagorean identity right here? And turn that sine squared into cosine squared. How do we do that? What would it be?
Sine squared into cosine.
Yeah.
It would be 1 second.
I'm just writing down the first one.
Sine.
Cosine plus
1 minus cosine squared, right?
It'd be
Are you talking about after you've distributed the negative?
1 second. Cosine
What are you asking?
plus sine.
I want to turn sine squared into cosine squared.
Okay, so the cosine squared plus the sine squared equals positive 1, correct? That's the
Sine squared plus cosine squared equals 1, yes.
And then we want to get negative.
Right, yeah, so you're skipping the distributing the negative.
Oh,
Yes,
okay.
yes. Yeah. So this will be 1 minus cosine squared theta. Distribute the negative, and we end up with cosine squared theta minus 1 plus cosine squared theta. So this would be 2 cosine squared theta minus 1. And then you would use one of these, this one, and get there. And you're going to end up with the same answer. This is probably simpler.
Yeah.
But they would both get there. I thought this was going to be shorter than it was. Okay. Your battery is running low. Well, maybe I should plug it back in.
Maybe you should stop being silly.
Oh, no, I can't do that. That's impossible. Okay. You still didn't say hi, whoever you are. Lurking. Okay. What other questions? None? Great. Let's do some more examples. Oh yeah, somehow I did skip a whole. I was right last time. My consternation at the end of last class was warranted.
What's consternation mean?
You're gonna have to Google it. Gotta learn those vocabulary words.
Excuse me for not knowing the word for once.
For what?
I usually know words.
You do have a good vocabulary atypically. That is true. I do as well, but there's words that I miss as well. Okay, so we're going to do this example. This is the same lesson. We have not moved on. This is the last lesson in this unit. When we're done with this lesson, then we'll have a test on Tuesday. Yeah, no, I said that last time. If the sine of x, it's actually theta, but you know, whatever. Sine of theta equals negative 7/25 on the interval pi to 3 pi over 2. These are nice little problems. I like these. Fine. What? Non-inclusive. It doesn't really matter on this particular problem, but yeah, non-inclusive. Find the sine of 2 theta cosine 2 theta. Oh, I just remembered who pronounces it that way. It's on what's that called? Crash Courses physics class. The lady that does those pronounces theta. Okay, great. Here, this is what we should have done as example 1 the other day, but it's fine because honestly, it's kind of almost better actually to do this in this order because, you know, this is kind of like a totally different chunk. We did 2 similar chunks last time, so it works out well. What should we do? What is a path that we could walk down? Okay, so almost certainly something with identities. That's true.
Okay, well, if we inverse sine that first one, we can figure out what the angle is.
Okay, so inverse sine this one, figure out what the angle is. So something with that, it might be useful to kind of shove this on a grid real quick. What is sine?
Y over R? No, X over R.
It's y over r. You were right. So it's y over r. So negative 7/25. So a triangle over here, right? This is theta. We've got negative 7/25. That's the triangle we're operating within.
Oh, we can,
Yes, that one.
what I'm trying to say.
I do. Pythagorean theorem, this puppy.
Okay, so
Negative 7, that doesn't really matter because, you know, squareds. But negative 7 squared plus x squared equals 25 squared. What's negative 7 squared?
49.
True enough, 49.
That's correct.
What's 25 squared?
It's 125, right? No, that's not correct. 625?
That was 4 something. Or 20,
625.
It is 625.
Had the idea, correct?
Yes, you did, and you got there. I was letting you confirm for yourself. Subtract the 49. X squared equals, what's 625 minus 49?
576.
576. And then what?
Root.
Square root both sides. So x equals plus or minus
Equals 24.
24. Which one of those are we keeping? The plus or the minus?
Minus.
The minus. That's right.
And you do that because
Of the graphy thing on the top. It's on the left.
Because which quadrant we're in. That's exactly right. That's all correct.
Okay.
Great. Now what?
Okay, what is 2 theta?
It's 2 times whatever the angle is.
Alright, so
find the angle through that.
We could find the angle. We could get a decimal equivalent. It's going to be something ugly, for sure. But we don't even need to know what the angle is because we have double angle identities, right? What is the double angle identity for sine?
2 sine theta cosine theta.
2 sine theta cosine theta. Let's do a little bit more notes jotting from what we figured out over here. So we can start kind of shoving some stuff. What is, we already know one of them, so one of them's easy. The sine of theta is negative 7/25, right? That's the given. What is the cosine of theta? Not 2 theta, but just theta.
Adjacent over hypotenuse.
True.
So negative 24 over 25.
True enough. And then what is tangent of theta in this problem?
It'd be opposite.
negative 7 over negative 24.
True, which would be positive 7/20. Yeah, those words that I'm trying to say. Positive 7/24. Okay, so jumping back over here, the sine of 2 theta would be 2 times negative 7/25 times negative 24/25. What does that turn into? Other than ugly. Actually, it might not even be that ugly.
336 over 625.
336 over 625, supposedly. The book agrees with you. So there's one of them.
Oh, we're just leaving that as that chunk. Okay.
We are. Okay. The cosine of 2 theta.
Can be a bunch of magical little things.
That's great. So let's pick the simplest one, right? Which one are we going to use?
2 cosine squared theta minus 1.
2 cosine squared theta minus 1. That sounds fine. We know cosine theta is negative 24/25. So that equals 2 times negative 24/25 minus 1. So 2 times negative 24/25 is what?
1,152 over 625.
That's the final answer or what I asked for?
God, what did you ask for?
2 times this.
You didn't square it.
Thank you. Now what I should have asked for, what is that squared? Whatever you just said. Ready to go. 1,000 something, right?
1,152 over 625.
620.
Get rid of the 2. I already put the 2 in there.
You already did the 2. All right, since you already did the 2, I'm going to make sure somebody else agrees. Somebody else punched it in. See if you get the same thing. Negative 24 25 squared times 2. has to warm up. Especially since you're using a phone calculator. Who knows what might happen.
I mean, I have my regular calculator, I'm just near.
I wasn't yelling about it. That's an easy way to make mistakes.
Negative 24 divided by 25.
No.
Yes. Negative 24 divided by 25, enter. Squared, enter. Times 2, enter. If you're going that route.
What? Can I just put it all in one?
You can as long as you use parentheses.
I'm so bad at using a calculator.
Ah, see, look at you. You cheated.
I got enough to see.
Okay, what's 1,152 over 625 minus 1? Something less stupid, but still stupid.
527 minus 625.
Wait, what? Minus? What'd you say?
527 over 625.
Okay, that's I don't know what I heard, but 625, that's the cosine one. And then tangent of 2 theta.
Is 2 tangent theta over 1 minus tangent squared
Theta. And we know that tangent theta is 7/24. So 2 times 7, oh, that'll at least reduce. That's nice. That's a 2. Over 1 minus squared, before I forget, 7/24 squared. That's not a 2. It's a 7. I was right to begin with. 2 times 7/24 is what?
7/12.
It is 7/12. And then 7/24 squared is what?
49 over 576.
And then what's 1 minus 49/76?
527 over 576.
Yep, that sounds right. Oh, except I didn't write 7/12. It's getting a bit of a mess, but this is where we are. What do we do now?
Okay, well then we can.
Yes, flip and multiply. Yeah, keep, change, flip, or whatever you want to call it. Extremes over means. Times 576 over 527, which I am actually going to write this whole thing out because I made a mess of the last step. So what do we get as our final answer?
Okay, well we get 4,032 over 6,324, but then apparently it reduces to 336 over 527.
326,
36.
36 over
527.
527. Yeah, that looks to make sense to me. Great, and that's the tangent 2 theta. Great, makes sense. Let's keep track of things as we go. Your first homework set, first part of your homework set is on page 3, whatever it is. Same thing we were just doing.
352.
Yep, 352. Numbers 2 through 8 evens. Great. Now let's do some solve equations bits. Yeah. Right here. I will leave it. Ugh. Bam. Did y'all know that the reason that Emeril Lagasse started saying BAM was because when they were first taping the Emeril show, or Emeril Live, or whatever the heck it was called, they were taping a whole bunch back to back to back, and the cameramen were falling asleep. And so he started doing that to keep them awake. And then it just became his catchphrase or one of them.
I'll be genuine, I did not know what sugar we were talking about.
This is before like Food Network shows like became crazy and there's like 5,000 things. He was kind of one of the OG Food Network people, and he did a live show, and there was a studio audience and whatever else and all the things. It was on like network television too. It wasn't even like Food Network. He was like Food Network before Food Network.
We did not have television, we had PBS.
That guy ever say hi?
Nope, nobody ever said hi. They probably aren't even there. They probably like opened it and then walked away and are eating donuts or something. Okay, solve. Cosine 4x plus cosine 2x. Is it cosine? Yeah. Yeah. Equals 0. Okay, what could we do? What tools might we pull out?
We can take out cosine 2 theta.
We can't.
No?
No, because that 4x is locked inside that cosine. That is not cosine 2x times cosine 2x. That would be cosine 2x squared. I know, it's twisty. Like I said at the beginning, this is cosine of 4x, not cosine 2x times cosine 2x. Yeah. Yep.
You also change the cosine 2x into its identity.
I think changing the cosine 4x into it, because then we would be in terms of cosine 2x, right? And they would all at least match. So I think doing this one with a double angle identity is going to be the better first step.
How do you do that?
Well, we've done that at the other day and today, right? What is the double angle identity for cosine?
There's 3 of them.
Sure. Pick which one looks like it's going to be easy. If so, in this case, as we're doing an equation, if there's one that keeps it all in one line without fractions, that's a great idea. If not, then we may want to like do whatever's easiest, right? So what are we going to use?
2 cosine squared theta minus 1.
2 cosine squared theta minus 1, right? So this would turn into 2 cosine squared 2x, right, minus 1.
Okay, I'm kind of following.
Good. 2x equals 0. This looks like something that we could probably factor. What do y'all think? We may want to rearrange it so it's easier to see. That is where we're going. I'm going to rearrange this in descending order. So I'm going to just commutative property, switch these two. And then, yeah, parentheses is a great idea. Cosine squared 2x plus cosine 2x minus 1 equals 0. We can even use this method if it's going to be easier to see. I don't know if anybody is using this, but this is a good strategy. Equals cosine 2x for being able to see ugly things. And then we turn this into 2u squared plus u minus 1 equals 0, right? Now it's easy to see that this can just be factored, right? Okay, so 2 sets of parentheses, and what's going to go in the parentheses?
2 cosine 2 theta.
2u, u.
And then I think minus and plus 1.
1 and 1, and 1 and 2, and we want a positive one, so minus, plus, follow our nose, follow our mouth. We can substitute our cosine 2 theta back in and turn this into 2 times cosine 2x minus 1 equals 0, right? And the cosine of 2x equals 0, right? We fall in, Except I should put a +1, shouldn't I? Great. So, what now?
Do we want to get rid of those double angle identities again?
We could. I think well, maybe. Yeah, probably. Let's probably go ahead and do them now. So what are we going to do now?
2 times 2 cosine squared theta minus 1 minus 1.
There should be another 2 here, right? And then this one is just 2 cosine squared x minus 1 plus 1 equals 0. Okay, pause. So we follow what's on the board.
Yes.
Yes, I think so.
Yeah.
Okay. Now what do we need to do?
Multiply, and then on the right one, you can put those ones.
So I'm going to distribute the 2. 2 times 2 cosine squared x is 4 cosine squared x, and 2 times -1 is -2. Minus 1 equals 0, and then yeah, this one, the -1 plus 1 cancels, leaving us with 2 cosine squared x equals 0. So over here, what should we do?
Okay, we should add the negative and the 2.
Yeah, combine like terms, right? I don't know if that's what you meant. Is that what you meant?
Yeah, that's what I meant.
Okay. No, you're good. 4 cosine squared x. Oh, this is not going to end up all stupid. Yeah, okay. When you try to think through too many steps in your head, things go awry. Okay, this one, what should we do?
Divide it all by 2.
Divide it all by 2. So cosine squared x equals 0.
And then on the right, we move the 3 over.
Mm-hmm.
4 cosine squared x equals 3.
Yes.
And then divide by 3, and we have 4.
Equals 3, and we end up with cosine squared x equals 3/4. What are we going to have to do there, kids?
We have to square root.
Yes. X equals plus or minus the square root of 3 over 2, right?
That's literally like a thing.
It is literally like a thing. That is true.
Okay, so we get cosine 0 and cosine plus or minus
Yeah.
3 over square root of 3 to 2.
X equals 0. So,
Well, that's that thing for sure.
what now?
We do the magical trick.
Let's do the easy one first. Where is cosine 0?
At 1.
At 1. Okay. Anywhere else? Infinitely many places.
Did it not give us, no, it did not give us a boundary, so how do we write the,
At 1. That's not even right. Why are we saying at 1?
why did I say 1?
I don't know why you said 1.
No, I was looking at the wrong number. I meant at pi over 2.
At pi over 2. That's true.
Pi over 2, and then also at that,
Where else?
over 2 plus interval plus n to pi where n is an interval.
That's true. I wasn't even getting to there yet. But yes, we do need to write all of them because it says solve, not write the solutions in this interval, right? So we are going to need to do that in a minute. Oh, look, there's a second person. Say hi and show up the other person. Okay. Where else is it pi over 2? Where is it pi over 2? Where else is it 0?
0? Okay, it's at quadrant 4. Quadrant 4 is pi over 2.
Here and here.
3 pi over 2?
Yeah, 3 pi over 2. Great. We'll write out all the things in a second. Let's leave that there, and then we'll come back to writing this out with representing everything, right? Let's go hit this one. So where is cosine positive square root of 3 over 2?
Pi over 6,
And then where else?
1 second. Ten pi over 6. So that'd be 5 pi over 4? No. This is what I'm trying to do in my head.
How about all of those? Why would it be all of those?
Right, because it's plus and minus.
Plus or minus, so it's all of them. So now that we've got the things, we gotta like actually write all. That's one set, one revolution worth of answers. So the answers in completeness are pi over 2 plus what?
2 pi.
2 pi n, yep, that's the period. Where n, actually we can probably do the n as a member of for all of them, that's fine. Member of what set?
Intervals.
Integers, that's what you meant?
I can't English.
Integers. So it's that and 3 pi over 2 plus 2 pi n and all the rest of them. And 5 pi over 6 plus 2 pi n and 7 pi over 6 plus 2 pi n and 11 pi over 6 plus 2 pi n. They're all a member, n is all a member of the integers.
So you're just writing out all.
Oh, that's a lot of numbers.
It is quite a few numbers. We did great on time. We did this is like as perfect as we've been in this class. Okay, so the other set of your homework, other piece of your homework is, so this and 24 through,
Same page.
yes. Do I want to hit those? Yeah, no, probably not. So I'm just going to make a list. 24, 26, and then I want to do 34 and 36, and 50 through 54, evens. And that's it. Goodbye.
So much for having free time this afternoon.
Oh. End stream. Not yet. I want to end it over here, actually.